We know that numbers can be represented by words. Like 1 dozen is equal to 12 of something. A pair is equal to 2 of something. A ream, as in a ream of paper, is 500 of something. 1 mole represents another number. It's just a very large number. And it's 6 sextillion of something. So the mole is just a number, a count of something. So, 7 groups of 3 to make 21 zeros. Or, scientific notation, 6.02 times 10 to the 23rd. Because we moved that decimal place from back here all the way over to the 6. Scientific notation, you put the first non-zero number in front of the decimal place, times 10, and that number tells you how many decimal places you moved it. It is a system international unit, a SI unit, just like a kilogram is for mass. The mole is defined against a known standard, the isotope carbon-12. It is the number of atoms in exactly 12 grams of carbon-12. So the mole has a symbol that you're going to use for this, and you're going to need to know this because you're going to start doing some math. So the symbol for a mole is a small n, a lowercase n. It has units, and the units are written as MOL. We dropped the E. So you can have, for instance, 2.5 mole of something. So this tells you I have 2.5 moles of a substance. So N will have a number associated with it, and the unit will be MOL. You have to write them both. You have to use units in this quantities in chemistry. It is a very important quantity in chemistry. It is a unit that represents the amount of entities or particles of a substance. Chemists deal with extremely small entities like atoms and molecules, so we need a number to make counting them practical. Right? You can't sit there with a magnifying glass and count out atoms. Doesn't work. 6.02 times 10 to the 23 is also called Avogadro's number. Avogadro's number in honor of Amadeo Avogadro. Is a capital N, subscript capital A, Avogadro's number. The units are particles per mole. Particles per mole. Do you understand what that slash means? Particles over 1 mole. You're going to be using that. Do you know what the 3 lines mean instead of an equal sign? It's the same thing as. It's the same thing as. If it's not equal to, there's no confusing. It is the same as. Okay. So the units, particles per mole, will change depending on the type of substance. So an example of a monoatomic element. Give me something. Lead. Okay. So element. Mono. Lead. Anything else? Give me something else. Anything. Sodium. Okay. The type of particle in Avogadro's number when you have a monoatomic element is atom. Abbreviation, atom. No short form. So it's going to be atoms per mole. I have 6.02 times 10 to the 23 atoms of lead per mole of lead. Okay? If it's diatomic, like hydrogen, we don't have atoms, we have 2 atoms, and we call them molecules because they are chemically combined together. So if you've got a diatomic element, like hydrogen, H2, we're talking molecules. Can you give me one other example of a diatomic element? Oxygen. Together, they make quite an explosion. Okay.
So the bottom thing goes into the abbreviation part?
Say that again?
The bottom thing goes into the abbreviation part?
That goes into the abbreviation. This is an example at the bottom, underneath. It's not even part of your table. Okay, so diatomic. The type of particle then is molecule. This one we can use a short form, and we say molic. Molic. It's short for molecule. So an example would be that we have 6.02 times 10 to the 23 molecules of H2 for every 1 mole. You okay with that? So monoatomic elements, everything other than the diatomics are atoms. Diatomics are molecules, short form molic. Covalent compounds. Right? Covalent or molecular. Can you give me an example of a molecular compound? Water. Probably the most used example of molecular compound in the history of teaching chemistry. Can you give me another one? Sasha. Probably the second most common example. Okay, so these are examples. Dihydrogen monoxide, water, or CO2, carbon dioxide. The type of particle is a molecule because the smallest entity that you can have, that is water, is a molecule. 1 oxygen, 2 hydrogens. And of course, the short form is a molecule. So 6.02 times 10 to the 23 molecules of H2O in 1 mole. So I'm giving you an example of Avogadro's number at the bottom.
Good morning.
Good morning.
Emily Dale with you.
Yes, she is.
She's available. I'd like to see in my office, please.
Okay, thank you.
Thank you.
You're going to like this one. Give me an example of an ionic compound. Yep.
Sodium chloride?
Sodium chloride. Can you give me another example? Anything.
I apologize for the interruption once again. Is Ethan Smith with you as well?
Yes, he is.
Great to see him down the main aisle.
Sodium oxide. MgO. OMG. OMG. Okay, the type of particle for this is formula units. They're like a molecule, but this is what we call for the individual units for an ionic compound. If we're talking about sodium chloride, for ionic compounds, it's always what is the chemical formula. That is your formula unit. It's like a molecule, concept-wise. Short form, F period, U period. Or FU. So we have 6.02 times 10 to the 23rd formula units of sodium chloride in 1 mole of sodium chloride.